Gianotti. You are a particle physicist and have worked at CERN, the famous high-energy physics lab you all know near Geneva, for a little bit less than 2 decades. And now you are renowned all over the world, yes, as the spokesperson of the experiment Atlas, which has the biggest particle detector ever built. You're the spokesperson who nearly 2 years ago, a little bit more, it was the 4th of July, that's for the Americans, you announced that a particle compatible with the Higgs boson was found by your detector, placed on the accelerator LHC, Large Hadron Collider, after something like 700,000 billion collisions or something like that. No, many. And you have received many numerous awards, among which I will cite only one, which has a special resonance here in Denmark, the Niels Bohr Institute Medal of Honor. Bravo. Rolf Heuer, since 2009 you have been Director General of CERN. It's a place you have been knowing for long. Between 1984 and 1988, you worked at a famous experiment of that time, I remember it very well, called Opal, on the electron-positron collider LEP, before LHC, and you became the spokesperson of Opal. And you know also very well another famous lab, DESI, near Hamburg. You were the research director there between 2004 and 2008. I noticed that in an interview, you said that you would like science to be a bigger part of the culture aimed at the general public. So I suspect you will appreciate ESOF, not only for its scientific communications and roundtables, but also for science in the city, which is just out there, you know, sharing knowledge with the general public. I would like to mention, because you told me so, that CERN has received the Unesco Niels Bohr Gold Medal. Bravo again. So as I told you, I would like to make a little exchange of questions. So Fabiola, I would like to start with you, because when you made your announcement, it was a thrill. You know, I wrote in my magazine that it was like like nowadays the World Cup of football. You know, it was thrilling. And in fact, this particle, the Higgs boson, does not exist anymore in our natural world. You had to recreate it in the accelerator, in the collider. But it did exist at the very beginning, the very early universe. So in fact, would you say that the LHC is a sort of time travel machine which gets us to the secret of the early universe? And what is the special secret of the boson? Because I'm not sure everybody has understood, even if you explain very well. You can say it again.
That's right. Thank you for this question, Dominique. So, first of all, the Higgs boson is a very special particle. It's a unique particle. It is so special because it explains why the other elementary particles have a mass. And among the elementary particles, we include two kinds of particles which are also very special, electrons and quarks. Electrons and quarks are very important because they are the fundamental constituents of atoms. So it means that everybody in this room, including you, Dominique, is made of electrons and quarks. We are all made of electrons and quarks, this microphone, my belt, everything. Okay? We are an ensemble of electrons and quarks and a lot of empty space. Now, if electrons and quarks are not a mass, so just pure energy, like the photon, which is just pure energy, it's no mass, then atoms will not stick together. Meaning that matter, as we know it, so chemistry, chemical elements, the atoms of which we are all made will not exist, or not in this form. So the Higgs boson is a key particle to understand why we are there and how we are there, and why our universe is made the way it is made. Okay? Concerning the first question, it's true. When we collide very high energy beams, we produce very high energy, and this energy corresponds to the temperature of the universe. You know, the universe had origin from a big explosion called the Big Bang 15 billion years ago, and then it expanded and cooled down. So the energy that we produce in our accelerators corresponds to the temperature of the universe at the given phase of its life, and the energy we achieve with the LHC corresponds to the temperature that the universe had 10 to the minus 11 seconds after the Big Bang, which means 100 of a billion of a second after the Big Bang, when the temperature was 10 to the 16 Kelvin, so 100,000 billion times the temperature in this room. So this is what we are doing.
Thank you. Thank you. Well, you know, I think we have a special audience who understands, but Rolf, I can't resist asking you, when you have to explain, well, to a taxi driver, or, well, that's things we have to do when we travel a lot like you do, or to your neighbor that, maybe about 9 billion or 10 billion euros were spent on this particle. How do you justify it, really?
Well, first of all, I don't justify it only on this particle, because there's much, much more beyond this particle, besides this particle. But this is the one which just received most of the attention. And Fabiola is absolutely right, because without this particle, frankly speaking, as she said, you could not exist. So you should be very thankful to us. We gave you the answer why you can exist. But I think you underestimate the general public. They are very eager to know and to understand what's going on in science and what we are doing. And the much I like to talk about science, I sometimes don't reveal that I'm going back to Geneva, because then they immediately talk about CERN. And I can give you one short example. In a taxi in Helsinki from the university to the airport, I had a very good taxi driver, and we were talking, and I had to reveal, I go to CERN, what you are doing, I'm at an international organization, CERN. And I said, yes. So I know what you are doing there. I watched the film Angels and Demons. And that made me so interested that I watch your webpage every day. And this is what we need. This is exactly what we need. And that goes back to bridging science and society. We are much too far apart. We have to talk more about this. We have to bridge science and society. This is a very important bridge. And we do it, by the way, also through arts. We have a new program at CERN. We are not only colliding particles, we are also colliding artists with scientists. And the result is fantastic. It's an eye-opener for both sides. So we have much more.
You told me, Fabiola, before you were about to talk today, that you would like to insist on the fact that all this research is a group research, and very, very big groups, very, very big teams, and young people inside, which is very exciting.
Absolutely. So CERN is really an example of collaboration and peace. These experiments, Atlas and CMS, were discovered the exposing is not only Atlas, it's two experiments. They are made of 3,000 scientists each, coming from all over the world, so more than 60 countries. And at CERN, more than 10,000 physicists from all over the world work together. And some of them really comes from countries that do not entertain romantic relationship, to be frank. And nevertheless, we work all together peacefully and animated by the same passion, because science does not see borders. Science is something that a very strong unifying element. And also, it's also true that in our experiments, in our collaboration of scientists, more than 30% of these scientists are PhD students, like me. Was a joke, sure. We are supposed to be just laugh.
Like you were. You started like that.
Yes, right. So actually, if you look at the age of our scientists in our collaborations, you see that about 50% of them are below 35. So it's science, young science, and it's a science made by people from all over the world. So it's not only a fantastic scientific adventure, but it's also a very, very important human adventure. It's very good to to grow in such an inspiring environment with people from all over the world. It's very good lessons for life lessons.
Yeah, you wouldn't know how to live only with Italians or only with French, or only with Danish.
Often people ask me, how is it work with people from all over the world? For me, it's natural. Diversity is fundamental because we are all different. We have all different fingerprints. There is no one person on earth with the same fingerprints. But the strength of mankind comes from this diversity. And so for us it's natural. Diversity is normality. We could not work just with Italians or with Germans, no.
Let's talk after the World Cup final and then we see. But I fully resonate with Fabiola, of course. Diversity is an opportunity. It's not a problem, it's an opportunity. That's it. And you get richer with this. And that was, I would have added, if you allow me, President Barroso, I would have added a sixth bridge to it. And this is bridging cultures and nations. Because we speak one language, and this language is science. Science is a universal language. And as Fabiola mentioned, we get scientists and engineers coming from different countries where the politicians essentially don't speak with each other. These guys realize, oh, the others are also humans. And this is fantastic. I mean, these are not so many people. We have only 10,000, 11,000. However, everyone is a game, and we have to start somewhere. This is important. This is also what I tell politicians in order to get my funding. Our funding.
One thing you can mention, in which is a bridge, as was mentioned by President Barroso, between fundamental research, frontier research, that's the wording, the elegant wording, and industry, is that accelerators, we talk about the fundamental ones like an LHC, but there are plenty of them, more than 30,000 all over the world, and they help people for medicine, for materials. So
there are around 30,000 accelerators all over the world, 15,000 in industry, 15,000 in the hospital, and the remaining are in science. So only very few are in science, and there's a spin-off of this for medical applications, for example for cancer therapy. Our instrumentation, which we are developing for our big experiments, can be used in locating tumors, for example, for visualization. And we should also not forget that we are not only celebrating 60 years of CERN this year, but also 25 years of the World Wide Web. And it has changed the world. And it was born at CERN in a seminal paper of one of the persons in the IT division who wrote a paper, and it had to be approved by his group leader, and this group leader was very good. He wrote on the paper, vague but exciting. That was the birth of the World Wide Web. And if you come to CERN, and it's worthwhile, you will see the first web server in this world, over there in our museum.
Now, what you're telling us shows how much freedom and liberty research needs. That's something that should be emphasized too. Fabiola.
Yes, freedom and creativity. And as Professor Heuer said, science is beautiful, but science is also extremely useful. So, and ideas are very important, and really the essence of science is ideas. So, for instance, very often people ask me, how could you coordinate an experiment made of 3,000 people? In these experiments, the hierarchy does not come from seniority, who is the boss, or the hierarchy comes from ideas. If the last arrived student has the right idea, the experiment follows that idea. So we really have to be very much open, and also make sure that when we have scientific endeavors, we are not over bureaucratic, because we have to make sure that the young people, in particular, and everyone, can express themselves with their creativity and idea. Without ideas and creativity, there is no science, as there is no art, to go back to what Professor Heuer was saying.
Young people and women, because in a way you become a sort of role model, are difficult to assume? You're not convinced?
No.
In physics, it used to be difficult to be a woman. It's not true anymore. That's that good news.
Well, I see, right. So if you take statistics, for instance, at CERN, we have typically, 20-25% of the physicists, scientists working in our experiment are women, and it's good to see this is the average, 20% the average, but then this percentage increased to 25-30% in the younger generation. So there is a very positive trend. Now, I must say, I like to stress more the word diversity, because it's not only women, gender diversity, it's also ethnic diversity, ethnicity, culture, tradition, working together in a coherent way while maintaining our culture, not denying it, while maintaining our tradition, because of course it's very important that people from all over the world with different habits, with different ideas, but diversity is a very important thing, and of course we should promote it. Be diversity in terms of gender, age. One nice thing at CERN is that if you go to the CERN canteen, the food is quite good, by the way, so you are all invited to come if you're willing to come. But Nobel Prizes eat face to face with the young students. And so this is very nice, very encouraging.
Before asking the question, the political question or the geopolitical question of the future to Rolf, I would like to know, and please forget finance.
That's difficult.
I would like to know which big discovery you would like to see happening in your field or others. Because we were talking about the Higgs boson to start with, but frankly, we don't know what dark energy is, we don't know what dark matter is, so there are enormous things which are over there and we still do not understand at all. So is there something you would expect for coming years?
We were discussing before with Peter about brain and fundamental science, that although mankind has made an enormous amount of progress since the beginning of life in learning and advancing, promoting knowledge, and 95%, as you said, 95% of the universe is dark. When you look at the sky, you see fantastic stars and planets. Those that you see is only 5% of the universe, meaning that only 5% of the universe is made of that kind of matter we were discussing before, atoms, quarks, electrons, the same metals we are made of. The rest is made of a form of matter and energy that we don't know, and we call them dark matter and energy, where dark indicates A, our ignorance, and B, the fact that this form of matter and energy do not interact directly with our instruments, so we deduce their existence in an indirect way. So clearly for me, the dream will be, and I guess also for Rolf, we switch on the LHC again in March 2015 at higher energy to be able to produce in an accelerator 100 meters underground across Switzerland and France a particle that could explain dark matter, 25% of the universe. This would be a great triumph for science. But again, we don't know how this particle will manifest itself. We have some ideas, people talk about supersymmetry, extra dimension, all these nice things. But at the end, I will say, nature decides. So we are open to what nature wants to give us. Surprises for a researcher, the best thing is a surprise.
So well, one thing the general public has to understand is that it was not only a necessity to find the Higgs boson, but now one has to study it in detail. And maybe it could be of the family of these particles which help understand this dark matter or dark energy. So how long will it last?
Well, first of all, I told the scientists the discovery was easy. Now the real work starts. Because now they have to investigate.
That's tough.
No, it's very encouraging, yes. No, we have a good atmosphere, so we can talk in that sense also in the laboratory. They have to find out, is it really this particle which is predicted by the so-called standard model, or is it something else? Does it have brothers, sisters? And that can take very, very long. Take as an example, you know twins, and they look exactly alike. The only difference between the two is one of them speaks one word differently than the other. Now you have to, first of all, find that beast, you don't know which one it is, and then you have to get it talking. And you have to get it talking in such a way that it speaks out exactly that one word so that you know what it really is. And that can take many, many years. And also, dark matter, as a director general, I have to tell you, don't expect it in the first few months. It can take some time, just so that nobody has a wrong impression. We have a program set up for the Large Hadron Collider until 2035, so for the next 20 years, in order to exploit all of it. In order also, coming back to the financing, to exploit all the resources which you have to put in, which one has put in order to take all of this up. And all these young people, they will do that. That's fantastic. I can only underline again what Fabiola said with the young people. This is one of our best chance. I mean, the young people, this is knowledge transfer. Everybody talks about technology transfer. Talk about knowledge transfer with the people. That's it. The young people, they go back, they spread the word about science. And if everybody talks about sustainable development goals, fine. But who is going to sustain it? You need the people for that. You need to educate the people for that. And that's also what we try to do, by the way, starting with 7 years old up to PhD students like Fabiola.
Wanted to add something, Fabiola.
We have actually covered a couple of two important qualities, in my opinion, for a scientist, and I would like to add the third one. So the first one we said is curiosity. The scientist has to be curious. Never give anything like fait accompli, as you say in French, but always ask yourself a question. The second one was mentioned now by Director General. Determination, perseverance. You're not going to discover something in 2 minutes. It's not a quick thing. You have to be stubborn. You have to be really determined. And the third thing, which is very important also to explain to our younger people, is modesty. We have to be very humble and very modest, because we realize that in spite of the fact that we know a lot, there is a lot that we don't know. Newton used to say, what we know is a droplet, what we don't know is an ocean. It's true. And thanks goodness, because it means that we will continue to improve knowledge, and science knowledge is an endless path.
Yeah, when you say determination, in physics, it's a story which started at the beginning of we could talk about the Greeks, but I will start only with the beginning of the 20th century, but you are in the continuity of that. And do you think that the younger scientists these days have this feeling of continuity? Because, we publish, or I used to publish, I'm not a scientist anymore, they publish, and at times, you have the feeling that the publication lasts a short time. So maybe I'm wrong, I hope I'm wrong. Are they inspired by the older physicists, the big guys?
On the publications, of course, it depends on the topic and on the quality of the publication. But yes, I think they have the feeling, I think they get it. And the best example is what Fabiola mentioned, if you go to the restaurant at Cern, where young and old are mingling, are networking, that they realize that they are building on the base which was done by the older people, and they realize, at least in our field, they realize they have to build the next base for the next people. Mm-hmm. And I think the fact, and here I have to come back to CERN, the fact that we are turning 60 this year means that we are, in that case, another type of role model. We are really a role model of what you can do when you have sustained support, when you have long-term support. And this is what we got from our European member states. We started with 12 member states. Today we are 21. And we have all the time through these 60 years the support. You cannot do such science without this support. But I think we have to go one step further, again, international. CERN is a trademark now. So you will not change the name, but you can change the meaning of a letter in the name. CERN, the E stands for Europe. Just recently we have redefined it from Europe to everywhere. So now CERN is open also to membership from countries outside Europe. Nonetheless, I think we have to keep our European heart, because the success, the sustainability of such a global lab is Europe, is a European flavor, and that we have to keep. Or, better, we have to tell the others how to get that flavor. That might be even better. And
to whom do you open it? Do you have preferences, or you wouldn't say them, of course, but no, give us an idea.
I can give you some idea. In January, Israel became the first member outside the normal definition of Europe. I'm very careful here, that's because the normal definition of Europe. But then we will hopefully soon have Pakistan on board as an associate member. And we are also going into the American continent. So we really want to go over into the other continents, because we have a tremendous amount of scientists coming from these countries, and so we want to be open for them. So there has to be an interest in this country by the scientists, by the community, and also, of course, by the politics, and then we are there in order to discuss.
Well, this is your policy, your feeling to make CERN evolve, but there are major discoveries or work to be done in new machines, or at least that's what I understand. So the thing which is not clear, maybe it's too early, but can you tell us a little bit how you foresee the future? Because we can have new machines, new round colliders, circle colliders, but we could have big straight machines like we did in the old days. So, and what for? What will it be for? A new brand of particles, or nobody knows? And who is forceful in this new race?
Well, here I can pick up again what Fabiola said, that 95% of the universe are unknown to us. Imagine, it took us 50 years, 50, it took us 50 years to now describe 5% of the universe. Isn't it high time that we attack the other 95%? Now the LHC will be the first step. And the LHC and other experiments somewhere else in the world will tell us which direction to go, circular or linear. Who are the big players? Well, there are the three regions, Asia. I'm sorry, Minister, I have, in that science area, we have three main regions, Asia, Europe, and America. I hope that we can also do a bit more on your region. These three regions are having roadmaps, and for the first time we have more or less a global vision for the field. A year ago we got the European strategy for the particle physics in the next 5 to 10 years, or longer, And just last month, the US did the same. We know the priorities in Japan, and it fits.